right, so we are back. Just a couple of iOS lectures to go. Today we will round out our discussion of MVC, of view controllers, and then also of some increasingly compelling features of these mobile devices like gesturing and actually being able to pinch and swipe and drag and so forth. We'll also look a bit lower level at some of the data mechanisms that exist, whereby you can save data, retrieve data, search for data in ways that are a bit more powerful than the property lists you've been using for the current project. And we will also look initially tonight at the process of provisioning. But this is a topic that will recur during this Thursday's workshops. If you can make those, do check out cs76.net, look at the schedule, and we have a lot of juicy iOS topics coming up this Thursday and next Thursday. So consult the schedule for times and locations. So for those of you with iOS devices, which is just over half of the class, reported having an iPad, an iPod, iPod Touch, or iPhone, this is the process by which you're going to actually run your own code on your phones. It's a bit more involved than it is in the Android world, in that you essentially need Apple's permission to install software onto your own phone. Per the project specification this week, you do not need to pay $99 or $299 to actually engage in this process. But if after the semester you want to submit your code to the App Store, that's at the point at which you would need to sign up for one of those commercial developer accounts. But so far as the course goes, if you are enjoying using the simulator but would really like to take it to the next level and install this software on your own phone, whether it's your own stuff, course examples, or whatnot, realize that we'll cover this in more detail this Thursday, and we'll also post instructions this week on the course's website. But in a nutshell, the process goes as follows. You sign up for a developer.apple.com account, which most likely most of you have done already. That's the free account. You then have what's called an Apple ID, which you might have had already if you used iTunes and the like. You will then, via a form on the course's website, tell us what your Apple ID is at some point, if you want to go this route. We will then respond via an automated email from Apple with an invitation to join the course's university developer account. At that point, you'll follow a number of steps online that involve generating a public-private key pair on your own computer. You'll essentially use the built-in keychain software to do this on the Mac that comes with your machine or the machine you're using. You will then generate what's called a CSR, a certificate signing request, that you will then submit via Apple's website to us, the course administrators, which we will then approve as being related to the course. You will also, around that same time, submit your device's unique device ID, which is a serial number associated with your iPad or iPod or iPhone. And once you've submitted all that information, we will again click approve. And long story short, you'll then be able to configure Xcode with that certificate after downloading it in such a way that you can then digitally sign your code or lecture examples or whatever it is you want to install onto your phone. And from that drop-down menu next to the play symbol in Xcode, will you be able to choose not just the simulator anymore, but your actual iOS device, assuming it's connected via USB cable. So in short, more details on the website to come. And also we'll be discussing this Thursday a bit in this workshop or in the seminar. But this is thankfully a process you'll only need to go through once. You don't need to do this for each and every app, because we will use wildcard identifiers to identify your apps. So you need only do this one time. Yes? Good question. Will the certificate allow friends or family to install it? No. So because it's going to be bound to your device ID, that's unfortunately one of the university restrictions. If you have one of the commercial developer accounts, you can then distribute your code to friends' devices, much like you were a private company. Other questions? Yeah?
If we have multiple devices that we want to test against, like an iPad and an iPhone, is that something we can do?
Good question. Yes, if you have multiple devices, most likely that's going to be fine, because we took a look at the numbers as to how many people have many devices, because Apple does impose a limit on us on how many we can register per semester. But it looks like based on who has what, that's probably fine if you have a couple devices. But we'll ask you in the form field to which is your preferred one if we run out of spots. Anything else? All right. Once it's all set up, it's nice because you hit play, it ends up on your phone, and everything is quite seamless thereafter. So let's go ahead and try to tie together a lot of the stuff we've been doing in recent weeks and start from scratch and try to build an actual application and see what kinds of questions we still trip over related to wiring things together in Interface Builder, with regard to declaring methods and properties in code, with regard to memory management, which seems to be a common sticking point. And let's see if we can't then take this example and add some layers of sophistication later this evening. So with that said, I'm going to go ahead and open up Xcode. and I'm going to create a new project, and I'm going to keep it super simple so that we get rid of any of the cruft that comes with the other templates, though we'll breeze through some of those a little later, that the ones we haven't looked at already. And I'm going to do one of these window-based applications. And my goal ultimately is going to be to implement a cash machine, an automated teller machine. So I'm going to call this project ATM. I have a choice at this point of choosing, recall, a company identifier, which for now I'm going to leave as edu.harvard. The reversing of this is intentional. It's a common convention in Java as well. The device family I'm going to leave as iPhone just because it fits more nicely on the projector screen here. And I'm going to leave unchecked core data and unit tests, though we'll talk about core data most likely next week. So I'm going to go ahead and click Next. I'm going to go ahead and save this on my desktop. And now I have an empty project. And so that we see where we're going, at the end of the day, my goal is to produce a little ATM machine that, for better or for worse, only accepts deposits at the moment. But once I have this working, I want on my screen a little touch application like this. The color should adjust itself in a moment. And at the top, I'm going to have sort of like a calculator, the amount of money I'm inputting, a little touchpad for my finger here, a greenish button, a reddish button for deposit and clear, respectively, and then my current balance, because I want to be able to type in 10, hit deposit, and deposit $10 into my account, but I want things to keep updating thereafter. So what kinds of UI elements jump out at you here? Just some quick review. So what are some of these UI views? Yeah. OK, so there's some UI buttons here, rounded rect buttons that I probably dragged from Interface Builder or created in code programmatically. Last week we saw 2 approaches to this. What else is probably on the screen here? Yeah. Yeah, so a UI label. It looks like this thing, balance, is probably a UI label. This probably is. Maybe it's a UI text field. But if I don't want the user to be able to edit this thing, I probably just used a UI label whose text property I'll modify. And indeed, the same thing goes for the thing up top there. It's just going to be a UI label that I'm going to create. Now, each of these things are UI views. So that is, they descend from the UI view class. And so surrounding this whole application is that thing called UI window, which is just a special UI view. And so the nomenclature here that you might see recurring in any documentation is that really what we're doing by dragging and dropping these buttons and labels onto this rectangular window is we're adding subviews, so to speak, to that window. So they're attached to that parent view. All right, so let's go back to code here, or rather lack thereof, for just a moment. Here I have my empty project. Notice at the top left, and I'll zoom in just a moment, we have all of the files, pretty much the minimum set of files that I get for free. So what do we got here? So main.m, recall that that's the file that really bootstraps the process, invokes a function related to UI application. But UI application then hands off control of this application to what? So the so-called app delegate, whose name can vary by project. In fact, by default, Xcode names it based on your project name. So in this case, I've got ATM app delegate and ATM app .h and .m at top left. Well, when starting any tour of code, take a look at what's usually the simplest, the .h file. And thankfully, there's very, very little going on here. But notice that ATM app delegate, even though this was just magically created from scratch, it's not any kind of special name, it does indeed implement UI application delegate, which is an example of a protocol. And a protocol in Objective-C is much like an interface in the world of Java. So that means this thing is going to respond to certain methods, hopefully, certain messages. Now it's got a property that's UI window, and that's useful because it's declared as an IB outlet, which means we can actually wire that to some other piece of code via Interface Builder. It will show up as a little thing in a menu there. So now let's look at the last file. The rest are pretty much helper files,plists, and such, which we'll wave our hands at. But the last code file is appdelegate.m. And even though on first glance this template, like a lot of others, might seem frankly a little overwhelming, notice that most of this is commented out anyway. So these are the several methods that are part of that protocol we mentioned a moment ago. But really the only one that's super important to implement, at least for this application, is this application did finish launching with options, albeit a fairly verbose one. So what goes on by default? Well, by default, in the simplest template, the window-based application, I am simply sending a message to the window. And self.window suggests that window is what's called a quick review. All right, so it's a property, so we're sending a message to the window, and because it's a property, I either connected that up in code, or indeed it's actually done in the nib file via the interface builder, so we'll see that in a moment. I send this message, make key invisible, which says make this responsive to the keyboard and make it visible, and voila, that's when I see the little grayish rectangle on the screen. And that's it. So at this point in the story, you're now in control, and you get to write all of the code. And generally, especially as we move more to an MVC approach, you don't need to write all that much in this file, at least for now, until you want to start handling some lower level details like the backgrounding of an application, running low on memory in an application, which may or may not apply for some of our simplest of applications. But if you're starting to do fancier things, especially for the student choice project, it's a lot better to free up memory that you don't need at any given moment in time, rather than having your application just die on the user, since they'll interpret that as a fatal flaw in your app and not just your way of handling low memory situations. So now let's look at the nib, and we're going to start plopping some things in here. So there's relatively little at top left. We have files owner, we have first responder, we have app delegate, and we have window. And indeed, if I right click or control click on window, we can see that this thing is wired up to that app delegate. And that's what enabled us to say self.window, because that's how we tied together that property with the actual app, with the actual window. Yeah?
Can you enter that in the file that you just did when you synthesize?
OK.
I was curious why the default, like if you're just kind of using a pointer to make your properties, and like you showed last class, where you just kind of draw from the view.
OK.
When they do things like synthesize, a lot of the examples I've seen from your website, they don't use like synthesize window equals underscore window, and then in the dealloc,
Mm-hmm.
your in your code use the underscore, your deallocated underscore.
Correct.
But they will put that in default. They won't put the one that by use synthesize underscore.
OK, and so the question ultimately is why? OK, so to summarize for the camera, the question is, why do we have, lately throughout a lot of the templates we've been seeing, and even some of the staff's code, do we have this convention, it seems, of @synthesize, property name equals, and then ivar name? Because we've seen previous examples where you can actually leave this out. And if you do leave it out, what is the name of the ivar that is assumed or dynamically created for you to back this property? Window. It's just called itself. Now, why do you see this? Well, Apple really started doing this in particular in some of their latest templates to create properties that are sort of reasonably named, but to ensure that they're backed by things that simply by convention begin with underscores, simply to make it ever so clear that something starting with an underscore is probably an instance variable, a private one in that, in some sense, even if it's not explicitly flagged as private. So it's really just a convention. You don't have to do the equal sign. And in fact, as we've seen in Objective-C 2.0, you actually don't need to even declare the ivar explicitly here. It will be dynamically created for you. But as was discussed on the bulletin board recently, there is a bug or a lack of feature in GDB right now where if you don't explicitly declare your ivar, you won't see it in the debugger, which is slightly annoying. A good question. So in dealloc, we have also seen, always really, that we're never calling self.something release, because best practices suggest that you should always pass release in your dealloc method, which is your very last opportunity to free up memory, is to always pass the release message to the actual instance variable, just in case you have a property that was implemented with a setter, or rather in this case a getter, that's actually doing something conditionally. Maybe only sometimes does it return the object. Maybe sometimes it lazily loads it. So in short, the whole point of properties is to kind of hide some of the implementation details. But at this point, the goal is to release that memory no matter what. And so you want, just to be super safe, direct access to the ivar. So in short, generally, you would see these days almost always do self.property name in every method in some class, but use the underscore or just use the actual ivar's name in dealloc, just to be safe. Excellent question. Yeah?
So, should we be saving our game state in the application did enter background method?
Your application's...
Or should we do that in the view did unload?
Saving state. Can you give me an example of state?
Well, for like this problem set,
Mhm.
in a game state, I mean, I just noticed this void application did enter background.
Void. Correct.
Delegate, is that where you would do it, or would you do it in view, did unload?
So we don't, okay, so good question. So if your application gets backgrounded by the user hitting the home button or a phone call coming in or the iPod screen coming up, whatever, you have an option to save state defensively just in case the user then double clicks the home screen and then kills the application, or just in case they reboot their phone, or just in case ... So we don't specify this in the specification. In fact, you can just assume that if the user reboots their phone, fine, they have to start the game over. But yes, these are the methods that would allow you to save state, say to a plist or to some serialized object in the iPhone's installation folder, if you want to make sure that the next time the user starts up the program, it resumes from a certain point. In view did on, so view did unload isn't so bad. View did unload just means that the view, like the widgets you're seeing on the screen, might have been released from memory, but that can happen all of the time. Even in the case of like the utility application, when you flip from front side to back side, well, when you flipped around to the back side, technically you don't need to keep all that front side UI view stuff in memory, especially in a low memory situation. So it's very common for views to be punted from memory, so you wouldn't need to worry so much about saving application state there, so long as you're actually saving it in your controller or somewhere other than the view. And according to MVC, you really shouldn't be storing anything important in your actual view. That data should ultimately be in the controller or in your model objects. Yeah?
The spec doesn't say anything about rebooting, but it says if the app is backgrounded, then it should resume.
And that it will resume, but that will happen for you because backgrounding does not mean terminated. So if you simply let the app get backgrounded and let it resume, it will continue on for this particular application where you left off.
That does not unload the view?
That could very well unload the view, but again, your views should be able to be reconstructed very easily from your nib file and where you've dragged and dropped things, or from your view did load method or view will load method. So you don't need to worry so much. You shouldn't be writing code that it assumes that the view will always remain resident in memory.
Okay, what about the display of how many letters you guessed and how many guesses you have to go?
What about the display of letters, the number of which letters you've already guessed?
In the middle of the game.
Well, it's fine to show that in a UI label, for instance, but you'd better be keeping that same information around in an NS array or in an NS dictionary or something in your controller class, for instance. So it'll exist in two places, aesthetically in the view and programmatically in the controller or in some model.
My question is, if the view gets unloaded, then at what point do you reapply that information that you say?
View will load, for instance. Or but if you're using nibs in this project, which you pretty much are, all of those UI widgets will get reloaded for you.
Okay, you mean it remembers the state of them, the contents of them?
No, it will only remember, no, it will only load from the nib what you initially put in the nib. If you want to repopulate those things, it's up to you to write code and say view will load or view did load. So let me circle back to this so we don't get stuck up on this point, but this is solvable, so let's field that during break if need be. All right, so let's actually implement real quickly a user interface for this thing. So the goal was to make a little ATM, and I'm going to go ahead and the right-hand side of Interface Builder, I'm going to start dragging and dropping some interesting things. So they're not called by their class names here, but they're a little simpler. So I'm going to choose label over here. I'm going to just drag this over here to make it as big as possible. I'm then going to right align it just because I think it would be aesthetically a little more interesting here. So I'm going to choose my attributes inspector. I'm going to move this thing over here. The font's a little small for me to see, so I'm going to change this to be, let's say, 24 point, and then I can continue futzing around however I see fit there. All right, now I'm going to need another label somewhere else, so I'm going to go ahead and copy this thing just because it's a little faster. I'm going to go ahead and align it in the same way. I'm going to go ahead and center that text. And this is going to be, just so I have a memory of it, I'm going to put a $sign there. This is going to be a $sign there. And then just for aesthetic reasons, I'm going to have a tiny little label here that just says, this is my total balance. All right, so we're halfway there. We've implemented half of our UI, and this, frankly, is the value of Interface Builder, in that you can do sort of rapid development or prototyping of your UI. Now I need some buttons. So I'm going to go ahead and drag a rounded rect button here. I'm not going to worry as much on the fly here as for aesthetics and spacing, but I'm just going to copy and paste them, and notice, much like any design program these days, things get nicely lined up for you. I'm going to go ahead and now copy these, so I can just do this quickly, do it again, do it quickly, and do it one more time down here. All right, so now this is going to be, what, the number 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to be deposits. This is going to be 0. This is going to be clear. OK, so now we have our user interface. And now we just have to start wiring things up. All right, so what kinds of things do we need to keep in mind? Well, ultimately, we want some brains of our little application here on the left-hand side to kind of drive the whole thing. And we'll call that generically the controller. So the controller is the guy that's going to respond to key presses and actually then send feedback back to the user interface, so that if I hit 2, I see on the screen 2. And so we need some bidirectional arrows here. So let's do that. Let's go ahead and drag, like we did a week or two ago, a very generic object over here, call it object. But preemptively, let me go up here, and I'm just going into my ATM folder. I'm going to say new file, because I want to create a very generic class here. So Objective-C class, OK, subclass of NSObject, that's fine. And then what do I want to call this thing? Just like we did last time, I'm going to call it controller. This gives me a .m and a .h file for free. And as you see, at the top left, we now have controller. There's nothing interesting in here just yet. This is the .h file. Notice it doesn't implement any protocols. It just descends from NSObject. And in the .m file is really nothing much at all. But now we have conceptually something that we can wire our user interface to. So here's this generic object, and that's not all that useful. So I'm going to go up to the identity inspector at top right. And recall that this is where you can specify exactly what kind of class you want this currently generic object to be. I select controller, and immediately now this thing is called controller. As an aside, there seems to be a bug in Xcode whereby sometimes it doesn't assume the name of the class, but you can fix it manually by double-clicking on it. Yeah?
I missed how you got controller in there. I mean, I
Sure.
created the file, but the
Good question. So very easily. On the right-hand side, you have this little menu of options. I just chose the most generic one I could, called object. And then I changed its class to be controller class. And I had to do the controller class manually at the top right under the so-called identity inspector, because that's something I made. It's not something that's shipped with the frameworks. All right, so now we get to do the fun part, right? Now programming is fun, because now we just get to wire things together here. So let me move this somewhat close together. What do I want to wire to what? Well, when I click a button, a number, what do I want to happen? Yeah, I want to call a function. I want a method to get invoked somewhere over here. And where should that method probably live? In the controller, right? If we weren't really trying to separate out the M from the V from the C, we might wire it up to the application delegate. Could work, but starts to get sloppy pretty quickly. So I'm going to go ahead and wire this up to the controller. But for Interface Builder to work, I need to create some outlets or IB actions. And right now, when I right-click on controller, there's nothing. This is, notice there's no circles filled in there. This is just a generic placeholder. So let's switch over to code for just a moment, even though we've seen little tricks where we can drag and drop and create template code, but we can do this pretty fast, pretty manually. I'm going to go to my controller.h file. I'm not going to bother putting anything inside there just yet. And I'm going to declare a property. And I want to call this property. Let me go ahead and cheat and make sure I'm consistent with our earlier story. I'm going to go ahead and call this thing, let's say, the balance label. So with the label for where I'm maintaining my balance. So I've got property, I've got non-atomic, I've got retain, I've got IB outlet, UI label, and this is my balance label. And the point here is I want to have a little outlet via which I can talk to subsequently the label that pertains to the user's balance. And similarly, do I want one for their deposit? And so I have these two things here. So quick sanity check. Non-atomic, recall, specifies that you'll actually get a higher performant getter and, or rather setter in this case, because you don't have to worry, getter and setter, because you don't have to worry about multiple threads accessing it once, which we don't in this case. We're writing a very simple program. What's the point of saying retain here? What's the point of retain?
Copy or increases the reference count.
Yeah, exactly. So this is specifying to the M file that when you synthesize this property, make sure to call retain on the pointer that's being passed in so that you're actually incrementing the reference count by 1 so that just in case I, elsewhere in my code, do a release on that same label, you can still hang on to it without it disappearing out from under you thanks to your retain statement. Alternatives to this include assign, and we've seen that before generally for primitives. IB outlet, this just specifies it shows up in interface builder. This is sharp defined to be the empty string, so it just goes away at compilation. And then these things we've seen plenty of times now. So now we can do a little wiring. So now I can go back to interface builder, and what direction can I drag where? What do I want to drag from what to what in order to wire these things up? All right, so the button to the controller. So if I hold, for instance, control on my button and drag to my controller, he's actually not lighting up. Because what did I define? Yeah, so I didn't actually define those actions yet. I did define the outlets, which means I can right-click on controller and go to either of these labels. And Interface Builder knows that those things should highlight because the IB outlet statement was next to a UI label. So this one here, I'm going to let go. I have two options, balance label or deposit label. This is my deposit label, where the number I'm typing in ends up. Now I'm going to go and do the same thing. Control-click on controller, drag over to balance. Whoops, not that one. Drag over to this balance and click balance label. So now I have arrows from the left to the right. Now I need to do the opposite. So I'm going to propose that when we actually call or press one of those buttons, we need a couple of methods to be available to us. And I'm going to preemptively say one of them is going to be an IB action. It's going to be called clear. And by convention, anytime you're sending messages from UI objects to your own code, you generally would specify that the parameter is called sender, the type is ID, even though in reality it'll be more precise. This is actually synonymous with void. It's sharp defined elsewhere to void, because again, that's just a little cute hint to Interface Builder. So this, I propose, will be the method that gets called when we actually hit the clear button. I'm going to also have, let's say, a deposit button, which is going to accept an argument as well. And then finally, I need one other, which I'm going to call digit, that's going to handle all of my digit presses. I could have 10 of them for 0 through 9, but that would seem a little suboptimal. So I'm going to go ahead and try to wire them all to the same thing. So now I'm going to go ahead and copy paste my declarations over to my M file so that I have some placeholders to fill in. I'm going to get rid of the semicolons, replace those with curly brackets. And I'm going to do it for digit 2. And now I've saved it, so I can go to my nib file, and now I can wire in the reverse direction. So what should I control click on next to finish the wiring? All right, OK, well, be more specific. Give me a button. OK, I heard clear. So let's go from clear over to controller. I let go, and I have 3 options, but that makes sense. I have 3 IB actions. I'm going to choose clear. I'm going to do the same for deposit, and I'm going to choose deposit. And now I'm going to choose 0, and I'm going to choose digits. And I'm going to do this fairly tediously again and again. And had I had the foresight to copy and paste after I wired one of them up, it would actually retain the wiring. So this is the slow and poor planning approach. What's that? Well, that's a good question. I have not actually tried that. That is the solution to that problem. Excellent. So now we did 3 at once. So in short, those 3 buttons have all been wired over to the controller, specifically to the digit method. So now we should be able to do a little sanity check. I'm going to go into my .m file. And I am going to specify, just as a sanity check, and infer from this that this is not a bad development technique, especially when you're getting acclimated. I just want to print that the clear method was called, and the deposit method, and the digit method. And I'll see this in my debugging output. All right, let's run it. I always feel it's good to actually see something working, even if it doesn't do anything useful just yet. So I compile. Oh, little error. I did something wrong already. Yeah, and it crashed. So what to do? Looks like main is buggy. How do I fix main? Yes?
Do you need to connect the controller to the file's
Good question. So do I need to connect the controller to the file's owner, otherwise known as the app delegate? Depends. If I need programmatic access to him, absolutely. And so that could be one point of contention. There was some yellow text, though, that popped up a moment ago that also suggested what our problem was. I'm actually going to go back here and remember that we had these properties, balance label and deposit label. Click on that. It requires that balance label be synthesized. So I'm going to go over to the M file. I'm going to quickly fix this. So synthesize. Balance label gets, by convention, balance label. And then I'm going to do this once more. Synthesize. Deposit label is the other one. So that at least fixed one problem. All right, and let's see if that was it. Now, mind you, I'm not doing the best thing here. I should be able to see that, undefined key. But it relates to balance label. So let's go ahead and recompile and see what happens to us now. OK, that feels good. Whew. All right, so we now have those properties defined. And that's good because previously we had wired the buttons, or rather we had wired the controller up to these labels, but we didn't actually have any storage space for one end of that wire that we had drawn. We didn't synthesize. Yeah? Good question. Could you instead do synthesize balance? Could you instead do this all on one line? Short answer is yes. It's really just a matter of style or readability, but that would work perfectly well as well. So for two things, fits very nicely. Sure, that would work great. All right, so now I'm going to start tapping away. $50. OK, it's not doing anything, but notice in the log, digit is at least getting pressed. So now let's just walk through verbally the rest of this rather than take it home completely manually. What needs to happen next? So I click a button like 5. The digit method is clearly invoked. What's passed to the digit method?
The object.
So the object, right? The so-called sender. It's of type ID, but in this case, because it's actually a button that's sending that message, it's sending itself, so it's going to be of type UI button. So what do I need to do conceptually now?
Figure out which one.
Yeah, exactly. I have to figure out which one. So propose some options here. 5 has been touched. 5 passes a message, namely a pointer to itself, to the method called digit, which is definitely getting invoked. How can we just figure out what's on that button now? Yeah?
Use the tag attribute, or there's a tag.
Excellent. Yeah, so that's actually the good answer. Let me pretend we said the wrong answer first. The wrong answer might be, or a suboptimal answer might be, we'll just read it from the label, right? We've seen how to actually programmatically edit the labels that appear on a button. You can do the button.text, and then, button.title. So we could just take what looks like a string, or what is a string, looks like a number, and do the equivalent of cast it to a number. But we're going to have to use a method for that because it's not actually a char, it's actually a string. But that just feels a little sloppy. So in fact, there are associated with the VUI objects that we have here this thing called a tag. And this is a special property that if I go over to my nib file and I select, let's say, the number 5, notice that over here on my attributes inspector, its title is indeed the number 5, but I could have said 5, and that really would have been a pain to convert, but it is coincidentally a number. But if I scroll down here, all of these things by default have a tag, a numeric ID of 0 by default. So the solution here, or one solution here, would actually be to go through these buttons and give each a unique identifier. And just to keep myself sane, I would propose that I make the tag for 5, 5. The tag for 6, 6. This can be done much more elegantly in code, right? You could create an enum, and you could enumerate all of these things and then associate tags with UI objects via constants. But here, since we're using Interface Builder so much, I would progressively go through each of those buttons, give them all a tag, and then read that tag property from the sender object in order to do the updating of the screen. So let's see the end result. I'm sorry? Tag is always an integer, has to be an integer by definition of the property. So let me go ahead and open up the cake that we already cooked. And it looks like this. A little prettier with my colors, but I'm going to go ahead and run this thing. And now notice what happens. I click on 5, and 5 shows up there. 0, 0 shows up there. So let's just take a sneak peek, but this is really just programming logic. Let's look at how we implemented digit here. Well, what did I do? I first cast the sender to a UI button, and I store it in a local variable b. I then update self.amount. So let's come back to that, but assume for a moment amount represents the amount that's currently on the screen. So it's some kind of int or float. Self.amount times 10 plus b.tag. So even though you're seeing this perhaps for the first time, what's going on the right-hand side of this expression? Why the times 10?
Shifting it over one decimal.
Yeah, exactly. It's a grade school trick of multiply something by 10 to shift it over effectively, then add the ones column. And the ones column, I can actually cheat and just do b.tag, b being the button, and .tag being the numeric identifier of that button, which thankfully we only have 10 of them. So it's great that they all have a number from 0 through 9. So now I get the total amount specified. And later I'll see that I've implemented a method called show, so that when I send that message to self, what actually gets shown on the screen? Well, now I have to use those outlets I wired up earlier. And it's wrapping because the text is the font's a little big here. But notice I do self.balance label. That's the label on the bottom of the screen. .text, which is its actual value, gets the result of calling NSStrings convenience method, string with format. And what does this represent? LLU, for those familiar? Unsigned long. I just wanted this deposit, this ATM to handle a huge balance, so I used an unsigned long. What am I inserting into that placeholder? Well, self.account.balance. And we'll see what account is in a moment. Assume for now this is an instance of something called a model. It's an implementation of a bank's account inside of which is stored my dollars. Then I update the deposit label. What do I do here? I call NSStrings string with format, LLU, and I specify the amount. So this show method was just a nice thing I factored out so I could update the screen as many times as I wanted. So finally, let's look at what this account thing is. And this finally is the M in MVC, which up until now we haven't really needed or had in M. But I decided to do the following. So I have in this final version of the ATM this class here that I again created just like controller at top left by saying new file, and then I chose a generic Objective-C class, and then I called it account, and I got almost this, but I added this. I added a property called balance. It's a long, and I specified a sign as opposed to retain. Why? And balance, to be clear, represents the amount of money in my accounts at the bank. Why is it a sign and not retain? It's not an object, right? It's not a pointer. It's not an object. It is just a primitive. So just like you learned in programming on day one, when you assign a value to a primitive, like an int or a char or a float, it's just going to copy those bits. There's no interesting memory manipulations going on. How did I implement account? Well, I actually did it fairly simply. I just have an init method, though I did synthesize a getter and a setter. I have an init method that by convention calls its superclass's init method, and only does self.balance get 0 if that returns true, which if that returns an actual object, which it always should. Self.balance is initialized to 0 just to be safe. And I then have a bank account. So this is an alternative, having an account class, to just putting my balance in like a global variable in the controller, which I could. But you know, a bank account probably has a PIN associated with it, a name associated with it. So this was a stepping stone toward actually really factoring out the M, the model, so to speak, from this overarching program, so that I could encapsulate all that information in something fancier than just a single global variable. Yeah? Correct. So NS integer and NSU integer for unsigned integer are type defs in the foundation class that just so happen to map to. They're not classes. No. So that's actually, it's a good point. It's a bit misleading, even though it's capital N, capital S, which almost always denotes some kind of class. For whatever reason, that is just a type def for primitives. So it's a slight exception there. And you'll see there are a lot of Apple's own methods that if they sometimes return integers or unsigned integers, just so that they're abstracting away from the underlying implementation of the primitives, they call it NS integer and NSU integer for unsigned. All right, so that's it. We didn't look at absolutely every piece of the ATM, but the other methods are just a few lines long, and seems reasonable to leave those for some at-home poking around. But any conceptual questions or implementation questions here? No? Yes? Oh, so this is, good question. So in my account.m class, file, I have an init method for my account class that's initializing the balance to 0. This account then must be getting instantiated, probably by my controller. So if I actually flip through the controller here, oh, interesting. We didn't look at this before, but because I've implemented almost all of my ATM program in the nib, but there's still a little bit of stuff I need to do, or I want to do programmatically. So there's this method, similar in spirit to view did load, but awake from nib suggests that pretty much my whole UI is bundled up in that .xib file. So as soon as all of that stuff has been deserialized, the buttons have been created, the labels have been created, the colors have been added, then this method gets called, and I have an opportunity now to do anything I want before my program really proceeds. So what I did was self.account gets the result of allocating a new zero balance account, and then I show those zeros on the screen via self-show. Excellent question. So the implication here is, suppose I told you at this point, I have a memory leak somewhere. Where did I probably goof? Not releasing this. So if I claim that I have a memory leak, or instruments shows me that I have a memory leak, one possibility could be that, you know, in this class called controller, I might not, in my dealloc method, have actually released that account object. Or if I didn't do that, I should have at least called auto release here so that it eventually happens for me. But we're OK for now. Yeah? It's a leak in that it's never deallocated. You ask the operating system for memory. If you never give it back, that's a leak.
But that won't make the instrumentation tool tell you it's a leak, will it?
It should pick up on that if you don't actually free that object at the end.
Okay. I thought the definition of a leak was that you lost the pointer, so you couldn't ever free it.
Semantics. That's a reasonable definition, but I would claim if you just forget to free it, it's leaked. Yeah. Good question. What's the trade-off of doing the view did load here? So view did load is called when your view does load, obviously, and this might happen when you have multiple. This might particularly happen when you have multiple view controllers, say in the case of the utility application, which we're using for the project, where one of those view controllers and its corresponding view sometimes literally goes out of view and therefore doesn't really need to remain resident in memory. I'm actually exploiting the fact, and then in my simple little application here, at least while this program is running, my view is always going to stay there because there's no other view that's going to occupy the whole window. So I don't have to worry about some of this being punted from memory. But if I did need to worry about that as is more likely to happen in the utility application case, then I would probably want to do it. I could do it there instead. Good question. Yeah?
What would happen if you remove the self-show from the awake from nib?
OK. What would happen if I remove this call to self.show? And just so we see where we're starting, here is the nib file by default. So here is my controller.m file. Let me save this, run the code. What I'm going to get is literally what I see in the nib file, which just looks a little weird because it says literally deposit instead of $0. So I used awake from nib as an opportunity to set it to 0. I could have done that in the nib, but I wanted it to be ever so clear to me, the programmer, that my code was working. All right. So feels like we can do better now than actually clicking on simple little buttons. What's so sexy about these mobile devices is that you can pinch and drag and rotate and all of this fun stuff. So let's take things up a notch and not just resort to these simple little buttons. Turns out that in iOS, you have the ability to implement what are called gesture recognizers. And a gesture recognizer can be attached to any UI view, and it essentially allows you to listen for these modern day events like touching and dragging with your finger, or using two fingers and doing what's called pinching, either inwardly or outwardly, putting down two fingers and rotating. So if you've ever used Google Maps or anything graphical on Android or on iOS, you're probably familiar with these gestures. Well, here are the gestures that we can implement recognizers for. So we can say, I want to listen for tapping on a UI view. I want to listen for pinching, rotating, swiping from left to right, top to bottom, or vice versa. For panning, so that's like on a Google map, clicking and just dragging the thing from left to right. And then long press, which you see once in a while where if you hold something for a couple seconds, then something interesting happens. So let's see now how we can start to implement something that's a little fancier here, but that actually leverages the same fundamentals we've been doing here for some time. So I'm going to go ahead and create a new project. I'm going to go ahead and create a view-based application, so a slightly more sophisticated template, but that will handle for me out of the box screen rotations if I want and all that kind of stuff. So I'm just going to get a little more helper code to begin with. I'm going to go ahead and call this, let's say, gestures. I'm going to leave these defaults as they are here. I'm going to click Next. I'm going to click Save on my desktop. And now I have a simple template. Let's expand the folders and see what I have over here. It looks like at top left, I've got an app delegate, a view controller, and a nib file. So these constitute the guts of this application. Let's see what I get for free in the nib. Well, it looks like my nib by default just has this empty application. Indeed, if I go ahead and, this is the bug in Xcode we encountered last week. Well, if the simplest fix for what we just saw, whereby if you're unable to run the simulator, because it's not among your targets at top left, frankly, is to recreate it, though you can adjust the build settings to fix what appears to be a bug as well. So I'm just going to start that story over. And now, thankfully, at top left, I actually have my iPhone, my iPad simulator, and iPhone simulator, which, again, for some reason, seems to disappear from Xcode 4 once in a while. All right, so here are those files again. I've got a view controller and a nib. Inside of this nib is not much of anything. I'm going to go ahead and build the code. And so in a moment, there is my starting point. So let's start to put into this application something interesting. I was poking around before class, pulled up Tommy's Facebook page, and I found something interesting. Let's go with this. This is a JPEG. You can use PNGs and other file formats, but I'm going to go with what I found there. And I'm going to preemptively take Tommy1, 2, and 3.jpg into my project just by dragging into supporting files. Over on the left, I can put them really wherever I want, but I'm going to go ahead and choose supporting files. And notice here, this is important, especially if you tend to save things temporarily on your desktop or downloads folder. You do want to copy them into your project so that if you delete them where they currently are, they still stay in your project. And there is Tommy1 now inside of Xcode. So let's start incorporating Tommy into my application. I'm going to go to my nib file. Tommy is at this moment in the story an image. So I'm going to go over to my little palette of widgets down here, and I'm going to find the one called image view. I'm going to drag this over, and I'm going to line it up so that it fills the entire window besides the menu bar at top. And then at the top left here, notice how I can specify a default image. So I'm going to go ahead and say Tommy1 so that if nothing else, I at least have an application dedicated to Tommy right now. Indeed, if I go ahead and compile and run this thing, there's my Tommy application. But that's all it does. It doesn't do anything really of interest, but at least it's a starting point. And now I'm wondering what Tommy sections examples will be like today. All right. So let's see. So we can tap on Tommy. We can pinch Tommy. We can swipe Tommy. Let's see what kind of gestures we can now apply to this UI image view. And to be clear, it's a UI view, so these recognizers can be applied to it. So what do we want to do first? I'm going to say that why don't we make Tommy a little temperamental, such that if you tap Tommy for more than a second or so, he gets annoyed and yells at you with a UI alert view, which we've played with certainly before. So I'm going to go ahead and wire this up. So what do I want to do? I'm going to go over to my view controller code into my .h file. And I am going to specify, I want to make sure I'm consistent with our printout here. I'm going to go ahead and specify this. I'm going to go ahead and specify in my view code here that I want to associate the following listener. So there's a whole lot of stuff that we get for free inside of this .m file. I'm going to start deleting stuff that I just don't care about. So memory, I'm going to pretend that we won't ever run into memory issues here. I will keep dalloc so I at least don't leak. I'm going to get rid of the view did unload. I'm going to go ahead and should auto rotate. I'm only going to support portrait orientation for now, just to keep it simple. And now I do want to use view did load, because once Tommy has been loaded from the nib file, I want to programmatically attach some gesture recognizers to him so that we can actually respond now to UI events on the screen. All right, so what might I do here? Let me get rid of the comments for just a moment. Oh, and as an aside, these pragma things, what are these all about? You see them in the fancier templates. So these are preprocessor directives that are actually compiler or IDE specific. So in this case, it says pragma mark, which is the type of pragma, and then it says -view lifecycle. Well, in Xcode, like in other IDEs, you have little user and friendly things like drop-down menus where you can select things. So all pragma is doing in Xcode is, notice where it says in bold view lifecycle with a gray line above it. It's just to help you, the programmer, organize related functions into that menu if you're a fan of using the menu. But that's all that does. I don't use the menu, so I'm going to get rid of that. And now what do I want to do here? Well, in view did load, this is the methods that's going to get invoked once the controller's view has loaded. And now this is my opportunity to now listen to manipulation of Tommy's image. Let me go ahead and do this. I'm going to go ahead and listen for the so-called long press, which is when you hold it down for a couple of seconds, give or take. I'm going to go ahead and declare a UI long press gesture recognizer. I'm going to go ahead and call this long press gesture. And I'm going to go ahead and use the UI long press gesture recognizer class. And I'm going to alloc one such object. And then I'm going to initialize it, init, with target. Now, target generally means what is the object that's going to receive messages related to whatever it is we're doing. So who do I want the target to be? It could really be any class, but I'm going to keep it simple and make the controller class be the target for any gestures that happen to be triggered. So any messages that get sent from the application are going to go right back to myself. And what action do I want to take when I receive a long press gesture? Well, I'm going to go ahead and specify that it's going to be the selector, that is the method, called handle long press, colon. Now, that begs the question, what is handle long press? But what I'm doing here preemptively, what I'm doing here preemptively is saying when a long press happens, holding the screen for a second or two, what's going to happen? Well, I'm going to invoke the action handle long press, and I'm using selector because, again, in Objective-C, you don't pass functions by pointer. You instead pass them with this wrapper keyword that figures out where in memory this function lives. So handle long press is now the method I need to implement. So how am I going to go and implement this so that the screen yells at me when Tommy's face is touched for too long? So let's go ahead and declare a handle long press method. It's going to expect as its argument a long press gesture recognizer pointer, which as always we'll call sender. And what now do we want to do? Well, all we want to do if we detect a long press is alert the user that he's been pressing for too long. So let's go ahead and do UI alert view like we did last week. Alert view gets UI alert view. How do I create an alert view? Yeah, so I alloc it first, and then this is the crazy long method name, init with title. So the title, let's just say, is going to be hey, and the message will be, let's say, stop that. And the delegate, what's the delegate going to be? I don't know for now, so I'm going to leave that as nil. The cancel button, all right, fine, we'll stop. And then the other buttons, I just want one button, so I'm going to leave that nil. So this is code much like we saw last time. And if I go ahead and hit enter, Xcode will nicely line up the colons for me. And now we have a call to init successfully defined. How do I now show this thing? All right, so that's show. And then once we're done with that thing, we can call release. And so now we have a method that apparently allocates a UI alert view object, call show, releases it, and that code is only going to execute when a long press has happened. I don't need to do anything in Interface Builder, it seems, right now, because all we are using right now, we haven't wired anything up in Interface Builder just yet, but we do need to somehow associate this recognizer with Tommy. So how do we go about doing this? Well, notice we left off I left off one detail here. Let me make sure I'm being consistent. Yep. All right, so in my viewDidLoad method, I need to do one other thing. I'm going to specify I need to have programmatic access to Tommy. So I'm going to go ahead and call this property non-atomic as usual, retain as usual, IB outlet as usual. This is going to be a UI image view, and it's going to be called, let's say, image view. All right, so I just need now a way of wiring this together. So now, what can I do? I can drag from my gesture view controller over to Tommy, let go, and now notice I have an outlet to Tommy so that now my code can actually talk to and hear from that UI image view. All right, let's go back to my code and now associate it with that outlet. So self.imageView is the getter that's going to give me a pointer to that object, and I'm going to add the gesture recognizer that I just created, long press gesture, and that's going to associate now that method, or that gesture with Tommy's image. And now that I've allocated this thing, I need to make sure that I long press gesture release. So now to recap, we create the listener, or the recognizer for that particular gesture. We associate it with the image that is Tommy. We release the memory, because if this image view wants to keep it around, it will take care of that the retain for us. And that method's going to get invoked when the image is touched. So let's go ahead and run this. Uh-oh. What did I do wrong? So same mistake as I did earlier. I did not synthesize image view. So let's go into my .m file. Go up to the top here. Synthesize image view gets underscore image view by convention. Now, good question. Don't I need to declare handle long press? Yes, I should. It may very well still respond there, but yes, let me go ahead and fill in that blank too by copying and pasting its declaration so that now anyone that also includes this H file knows that that method is implemented. Good catch. All right, let's run this thing now. No crash. And now let's try clicking on the image. Fortunately, it doesn't really work with a keyboard here. So it's time now to use my little certificate that I installed in advance. So I went through the steps I alluded to earlier, whereby you create a public-private key pair. You then submit it to us. We then create a quote-unquote provisioning profile for you. And that what you then get on your screen is going to be this. I'm going to go to the top left, switch the target to my iPhone. I'm going to go ahead and click Run Now. And it's building. Building. Icon is now on my screen. All right, there is Tommy. All right, coming into focus. Now if I hold on the screen, oh, damn it, I forgot to wire something up. I had it, never cross your fingers during a demo. All right, what did I forget here? Okay, so it's good that I tripped over this earlier today because I know the solution already. It turns out that with UI views, you can actually specify if you want them to be responsive to user input. And by default, an image view is not actually responsive to user input. It's really meant to be something static. So it turns out if we look over on the right-hand side under the attributes inspector with Tommy highlighted, notice that I need to enable user interaction. And then as a forethought to actually implementing pinching or swiping, I'm going to go ahead and implement multi-touch so that it actually listens to multiple fingers. Now I'm going to go ahead and save this. I'm going to go ahead and go over to the phone again. I'm going to go over to the camera, recompile the code. It's building. We should see in a moment Tommy's face. Come on. And now I do a long touch on the image. There it is. Thank you for that. OK. Let's go ahead and take our 5-minute break, and we'll implement some more gestures in just a bit. We left off with Tommy here on the screen, but I'm getting a little bored with this one image of Tommy. And actually, I'd like to do something similar to iPhoto, whereby I can swipe from left to right or right to left and actually change the photo of Tommy that we actually see on the screen here. So to do this, I at least am going to need to have some kind of data structure containing all of the various Tommies, as we will call them. And we're going to go ahead and call this, let's say, an NS array. So let me go back to my .h file. This is, again, is our viewController.h file. And I'm going to go ahead and declare a property that is going to have non-atomic attributes. The retain attribute, it's going to be an NS array. And it's going to be, let's say, called Tommies. And I'm going to store inside of this Tommies array not just one, but 2 or 3 or more JPEGs this time. Because recall that I did drag a total of 3 of them earlier. So now I'm going to go back to my .m file, and I need to now populate this array. This is not something I can do in my nib file, because now I actually need to put these things into an in-memory data structure. So I'm going to go back to my viewDidLoad method, which again gets called right after your view has loaded, and maybe there's one Tommy there already, but that's OK. We're going to go ahead and load a few more in memory. So I'm going to say self.tommies gets an NS array. And I'm going to go ahead and alloc this. And I already know the names of these things in advance. So I'm going to go ahead and init this thing with the following objects. Tommy1.jpg, followed by Tommy2.jpg, followed by Tommy3.jpg. Now, there's perhaps an opportunity here for a loop to make this a little more elegant, but 3 is a pretty finite list. I'm comfortable just hard coding them in for this example. So I've got Tommy1, Tommy2, Tommy3, and then it's terminated by nil, which is, again, necessary for an NS array. Don't leave that off, otherwise bad things happen. So now I have this thing ready, and I'm actually going to go ahead and declare one other property. I'm thinking that if I'm swiping from left to right, I need to keep track of which image is there so I can figure out which one comes next when I actually do swipe left or right. So I'm going to go ahead and declare another property, or I could just do this as an IVAR. It doesn't need to use retain, because this thing now is just going to be an integer. And I'm going to call this index. So index is going to be the number of the Tommy image, the index of the Tommy image that I want to actually display on the screen at any one time. So by default, I'm going to very clearly say that the index is 0. But as it turns out, in the nib file, because I hard-coded Tommy1.jpg as the default, it's already going to show up as Tommy1 as the default. But I could have done that programmatically if I wanted to, as we saw last week when we didn't use Interface Builder at all. All right, so now I have to somehow listen for these things called swipes. So I'm again going to create some gesture recognizers. I'm going to go ahead and do this below the other ones. We'll leave the long press intact since it shouldn't really interfere. And I'm going to go ahead and listen first for the right swipe. All right, so this time I'm going to use UI swipe gesture recognizer. And this guy is going to be a, let's say, swipe gesture. And this is going to be a UI swipe gesture recognizer. I'm going to alloc it just as I did before. And let me scroll down a little bit. Font is wrapping a bit. Let's kill this. I'm going to alloc that. I'm going to init with target. And what do I want the target of this recognizer to be? Self. It could be any class, or any object rather, but I'm going to keep everything self-contained. And what do I want to invoke? Well, this doesn't exist yet, but let's go ahead and assume that I'm going to implement a method in just a moment, like before, called handle swipe. And we'll go ahead then and close my brackets. So now I've created in memory an object that is whose purpose in life is to recognize the swipe gesture. But which swipe gesture? Well, let me go ahead and specify. So swipe gesture dot direction is going to be set to swipe gesture recognizer direction right. However, as an aside, that's the default. But I'll be ever so clear by actually updating that property. And now what do I want to do? I'm going to go ahead and, just as before, add to my image view, which contains Tommy1 at the moment, the gesture recognizer that I just allocated. And at this point, if that guy wants to keep it around, it can go ahead and retain it itself. I'm going to go ahead and release that memory. So in short, we did exactly the same thing, but this time using a UI swipe gesture recognizer instead of the long press version. Yeah? What would be the syntax if you're putting in the action for?
For a function that takes several parameters instead of just the one.
Let's see. Let's see where. Oh, here. Oh, OK. So when the selector is the name given to a method devoid of its internal parameter names. So you would, if it was, for instance, init with foo and bar and baz, you would say init colon with foo colon and bar colon. So you would just put the colons, no spaces, and no internal parameter names. And so in fact, it was important that I actually specify earlier the colon after long press, because recall that the handle long press method I implemented took one parameter. It didn't need to, but it did, so the colon denotes as much. So that's how you help tease those apart. Good question. All right, so now listen for right swipe. Now I actually have to implement this method. So before I had a method called handle long press. Well, this time I'm going to have handle swipe. And this is going to take a UI swipe gesture recognizer pointer, generically called sender. Let me go ahead and copy this. And it is yelling at me. Let me not make the same mistake of failing to synthesize for a third time tonight. Let me go ahead and do both of those at once. Let me go up here and synthesize my Tommies. All right. Let me go ahead and synthesize my index. And now those yellow triangles should go away. And now I need to actually implement this method for swipe recognition. So here we have this method. All right, so conceptually, what do we need to do here? Well, we need to distinguish first the direction of the swipe. And you might have seen briefly with the context-sensitive menu that there's right, which I went with, but there's also left, up, down. So it feels like an opportunity for a switch statement or an if, else, if, else, if, else. Well, let's go ahead and distinguish these things from each other. So let's go ahead and handle the swipe. Handle the swipe, and let's figure out first the direction. So UI swipe gesture, whoops, UI swipe gesture recognizer direction is going to be called direction, and this is going to be the result of calling sender direction. So it turns out that a swipe gesture recognizer object has a method called direction that will return to you that constant that effectively tells you up, down, left, or right. And so I'm going to store that direction inside of this thing here. And it's just yelling at me in yellow because I've not used that thing yet, but that's OK. So let's go ahead and do a switch and switch on this direction, even though it's uppercase. So actually, here's another example. This is actually just an integral constant, even though it looks like, based on the capitalization, that it's actually a object. It's not. So the case I'm going to listen for here is UI swipe gesture recognizer direction right. And so now I need to decide what to do, handle right. What I need to do if I want to handle that case. Now let's go ahead and let's do this. So I'll put this here, right? Let's just clean this up a bit. And now let's preemptively get ready for any other swipes. So let's top. This will be top. This will be down, down. And I'm doing this only because Xcode, with its static analyzer, will yell at you with yellow triangles if you don't implement cases for all 4 of these, even if you don't care about all 4 of them. Oh, sorry. Thank you. Up. Up, down, right, left. Excellent. All right, right. And change this to left. OK. Unfortunately, this doesn't do anything in response to the gesture, so now we need to decide actually how to handle this. So what do we need to do? Well, we've got an array, an NS array called Tommies. Inside of that are 3 NS strings, Tommy1, Tommy2, Tommy3.jpg. So now I have to decide programmatically which of these images I actually want to show in response to a swipe. So let's assume to the right that I want to increment. I want to go from 0 to 1 to 2, back to 0 in that array of 3 objects. So I'm going to go ahead and update my property, self.index, if you have swiped to the right, is going to get the result of the current index value, which initially is 1, and then add 1 to it. All right, I need to be a little careful here now, though, because if I keep swiping, 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 I'm going to very quickly overstep the boundaries of this array. So if you think back to Programming 101, we can use the remainder operator here pretty nicely and wrap back around from 2 to 0 so that we don't overstep our bounds. Now, how do we get 2 programmatically? I should probably at least infer this from my array of Tommies. So I'm going to go ahead and say self.Tommies. Give me the count of Tommies there. And now I've updated index to be the result of adding 1 to it, but then handling any wraparound properly. All right, now that's not enough to just update the index. Once I've updated the index, I actually need to now update the actual image. So let me scroll down here and update Tommy. I have self.imageView, and I'm going to go ahead and update the image view to have an image that this time is a UI image. And we did not do this in code before because we set things up via Interface Builder. The image I want is image, whoops, forgot my equal sign, UI image, image named. And the name I want to give it here is what? Yeah, so Tommy's bracket index conceptually. So how do I get at this? Well, self.Tommy's. And then remember, with an object, when you're actually using NS arrays, you can't just do the bracket notation. You need to call the object at index method. And what index do I want to do? Well, self.index should do it. So this is going to create for me a new UI image object. It's going to be instantiated with the image named, whatever is actually in my array. And so now at this point, that should hopefully update my image. Do I need to call release? Since I've just created, it seems, a UI image object. All right, so no. So again, no. Unless you've called alloc or retain or copy or new, you don't need to call release. So even though this thing is, in fact, returning a UI image object, what must this so-called convenience method be doing? And I say convenience in that it feels like it's returning an object, but you're not actually calling alloc yourself. Yeah. Yeah, so it must be auto-releasing, so I don't need to worry about it there. All right, so now let's cross our fingers. And let me go ahead and connect the USB cable to the actual phone. And if we've made no mistakes this time around, I'm going to go back to the document camera here. I'm going to go ahead and compile the code. All right. Oh, I see it in the simulator. Let's change it to the phone. All right, so here it comes. It's building. It's building. Here it comes. It's going to replace the icon that's already on the screen. It's going to launch the application automatically. And remember, we can still hold Tommy, and he yells at us. And now if I, let's see, swipe right. There's Tommy 2 or 1. There's another Tommy. There's actually a surprising recurrence of these kinds of faces in Tommy's profile. But now we have it, right? This is feeling very iPhone-like. It's not quite as sexy as the stuff that ships with the phone, where they have a little more animation, but it's definitely changing the graphic, at least in that direction. The other direction doesn't seem to work yet. So we could go in and add the other direction. Instead of doing plus, we could do minus, but we have to be careful not to wrap around into negative numbers. But now we have two such recognizers. We've got tap, and we now have the swipe. So let's do a little better than that. And rather than walk through all of the code manually, let me go ahead and open up some prefabbed code this time called transformations. And look at some, let's look at some translations and scaling effects. All right, come back on. All right, so let's go ahead and open up this. Oh, and as an aside, for those wondering, we did not end up printing these because we weren't sure we would get to these today, but we will make the PDF available online tonight. In fact, it's already up there if you have your laptop for the following example. So this is transformations.xcode project. All right, so you'll notice that in advance, I actually did one thing, which was kind of nagging me about the other example. Oh, let's quit this. All right, and a little trick with Xcode sometimes. All right, we should be back. OK, let's open up transformations. So I did one little nicety here. So this is sort of icing on the cake that you're certainly welcome to play around with on your own. But Xcode 4 actually makes it very easy to do some sexy things like have 3D icons and little splash screens launching up. You can read online if you just poke around for the specifications for these images. Generally, they need to be ping graphics. For your icon, it needs to be like 57 pixels by 57 or 114 by 114. Turns out that at least using Xcode, you can pretty much make the image as you see fit in Photoshop Photoshop or some equivalent program, then just drag it. So in fact, on my desktop just a bit ago, I had a 57 pixel by 57 pixel version of Tommy there, and all I had to do was drag the file from my desktop to the little placeholder there, let go, and voila, when I burn this version of the program to my phone, what I'll actually see on my desktop isn't just a lame little white icon. It will actually be a little glossy Tommy icon there. And you can do a higher res one for the iPhone 4 on the so-called Retina display. Yeah? Good question. Why didn't the word direction in the previous code have an asterisk in it? It wasn't a pointer. So it, very similar to NS integer, NSU integer, even though it looks or is named as though it kind of should be a class, it's actually not. It is simply constants, so numeric constants. You would check the documentation and it would tell you exactly what data type it is. And so that's how you know. Good question. All right, so let's poke around in here. Looks like in my app delegate this time for transformations, there's actually nothing really of interest. This is boilerplate code that came with the view-based controller that we started our previous example with. So I can focus all of my attention on the nib file, which in main window.nib actually has nothing. But notice that it does mention a transformations view controller. So that suggests that the brains behind this program is transformations view controller. And indeed, it's in this nib that I put that initial image of Tommy in exactly the same way. This time I remembered, though, to check those two boxes for multi-touch enabled and user interaction enabled. So now let's see what we're going to go ahead and do here. So I've defined a couple of different details this time. So one, I seem to have an instance variable this time. We'll come back to that, but the teaser is that I need to somehow remember in the following example that as I start to pinch and to scale Tommy bigger and smaller and actually move him around the screen, not just swipe to another image, but take one image of Tommy and blow it up or shrink it down, I need to be able to remember where he ends up when I lift my finger from the screen. So this instance variable is going to help me remember the so-called translation of Tommy, which means his offset from his original coordinates. That's what a translation is. So here are some properties. I have, again, an IB outlet to the UI image view. That's copied and pasted from before. But now I also have one other property called scale. And this, much like this instance variable, is going to remember what the current scale factor is of Tommy, so that if I really am getting bored, I can pinch and zoom in on Tommy, then let go, do it again, do it again, do it again, and it can be a cumulative effect to actually zoom in pretty much infinitely unless I bound it. I'm going to have another array of Tommy images, though actually I'm going to remove this. That was a little overzealous copy-paste because we're only going to have one Tommy this time. But I am going to have two different I'm going to have two different methods this time. A handle pan, panning meaning dragging Tommy from left to right, top to bottom, and a pinch gesture this time. They're defined identically to before in terms of their structure. So that means the real magic is going to happen in this M file. So there's a little more going on this time, but let's try to make a little bit of sense of it. And yeah, I didn't need this Tommy's array, but I'll clean that up after. Let me go back here. Let's take a look at which is the simplest of the two. Let's look at pan first. So panning involves this. And let's go ahead and spoil the result. Let's install Tommy on this phone here. So I'm going to go ahead and build this on the hardware here. All right, building. Here we go. There. Oh, you saw the much sexier icon this time. There's Tommy's image, and now I'll need one finger to move him around. So now we have this effect. So it seems to have become detached from the background. And then if I use two fingers, I can actually zoom in. We'll make it funny, and zoom in, and zoom in, and zoom in. All right, so there's Tommy at 3x or 4x factor. All right, and then we can pinch to zoom back out and move him back in the center of the screen. So familiar kind of gestures as you might have seen on actual hardware. So what do we do when you detect the pan gesture? We'll ignore for the moment how you wire up the pan gesture. Let's just suppose that the phone has detected that my finger is moving from left to right, up or down in some direction. So we want to translate Tommy. We want to make a linear transformation of his rectangular object on the screen. So we're going to go ahead and do this. We're going to declare a CG point, core graphics point, and we're going to call it translation. A point really is just xy. So there, it's a struct containing xy, and that's why there's no asterisk this time. It's not an object, it's just a C struct. And we'll see next week, too, with some of the core graphic stuff, a lot of it is really C-based, so you'll see slightly different syntax akin to our very first lecture on C. So what am I going to store in the translation? I'm going to ask the sender, what is the translation in view for the image view? In other words, what was the relative translation that happened? In other words, how many pixels did you move up, down, left, or right? Something like that. And we're going to store that answer in this thing called a CG point. Now, what am I going to do next? I'm going to declare for my transform here a scale variable and a translate variable. And I'm going to go ahead and make a scale. So again, these are all core graphics type functions. They're C-based. And this one takes 2 arguments. I'm passing in scale and scale. Now, what's going on here? Let's ignore this for a moment. So it turns out that this code is a little more complex in that it actually fixes bugs that would have arisen if we actually implemented this in the simplest way possible. So let me go ahead and just temporarily rip out anything related to scale. Let me go ahead and get rid of this. And let me go ahead and get rid of this. And then I'm going to get rid of this. And I'm going to get rid of this. And that's all we're going to do for now. So I figure out by what xy length has Tommy been translated, moved on the screen, and then I call this transform function. And I pass in Tommy's current location, which is translation.x, plus the new translation. So assume for the moment that underscore translation x is his original coordinates, 0, 0. So initially, let's simplify this further, he is at the origin, so let's get rid of this. And let's get rid of this. And what this affine transformation function is going to do for us is it's just going to create in memory a struct whereby this xy coordinate is going to be Tommy's new origin. That's it. But then we need to actually update the image. So we need to tell the image to go there. So when the user has simply touched and dragged, it's only the finger physically at that point in the story that has actually engaged in a translation. The image is not going to move unless you programmatically in code say, follow that finger. And so the code we're now writing is to take as input where the finger has gone, the translation variable, and then we're going to update the sender's view. Recall that the view contains the image. We're going to update its transform property. And thanks to a neat setter implementation of that transform property, when I pass in the result of the math that I just did, it's going to move the image along that same path to that same xy coordinates. Now, the additional complexity in this code derives from this. I wanted to have a program that not only lets you click and drag Tommy over to the left, right, top, bottom. I also wanted to be able to pinch in and pinch out and zoom. But the catch is that I need to remember all of these various transformations. And the gotcha is, and you can see if you go ahead and dissect this at home, if we scale Tommy up, that would effectively move the corners of that image, thereby incurring a bit of a translation, if you will. So if I'm not remembering the fact that a scale is actually having some effect on the actual image, I'm going to actually see a lot of jerkiness in the image, whereby if I click and drag Tommy and then pinch, he's going to be magically recentered for just a moment, and then he'll start scaling again. So in short, what I'm ultimately doing is concatenating together 2 matrices, essentially, 2 transformations, one being related to scale, one being related to translation, so that we're moving and or zooming him together, zooming him up or down based on past behaviors. So let's just take a look at this one conditional here. So what's neat about these gestures is that some of them are actually continuous. So as you move and move and move your finger, guess what keeps getting called? The same method, 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 method. But you can detect when the finger has been lifted up by checking if the state of that gesture recognizer has ended. Finger has gone up. And that's the point at which I now want to remember, OK, how far did we move Tommy? Because I want to remember that final total translation, and I want to store that in this instance variable called translations, its x-coordinate and its y-coordinate, so that the next time my fingers go down on that image and start dragging again, all of these translations can be additive. In other words, it's not enough to just move the image while the finger is moving. I want to remember where it ends up so that the next time I put the finger down, much like you would on a Google map, we can then add the previous translation to the next one.
If you didn't have the if statement, it should still work, I would
Good question. So would it still work the next time? Good question. So the next time you actually move it, it would be reset to the origin if you weren't adding in the previous translation.
No, I'm just saying you just took the conditional out. You did the two lines of code. Just remove the if part of it.
Oh, you would actually be, a good question. If we removed the condition and kept doing the addition again and again, you would actually be adding it too much, because when the continuous sequence of events are firing, for instance, suppose that the translation is moving 1 pixel, 2 pixels, 3 pixels, you would then be adding a geometric series of numbers, 1 plus 2 plus 3, and you actually only want to add the last number in the events that fire. Yeah?
So this translation variable only works, if you had 2 images, you would need 2 translation variables.
If you had 2 images, how are they laid out? What's the...
So they're both on screen. You drag one, that gets populated to this translation. Now you drag the other, that gets populated to the translation.
Correct. So what happens if you have 2 images? So in this example, we actually only have Tommy1.jpg. So it was an accident that I kept the array in there when I copied and pasted the previous code. So yes, if you actually had 2 images, you would somehow want to distinguish those 2 when this event is fired. But I'm safe right now because this method has only been set for one UI view object. So if we had 2 UI view objects, we'd have to tag them somehow or somehow distinguish them and have separate.
So the information about where the object is on screen isn't a part of the image view. You can't pull the image view.
Oh, you absolutely can. So you can ask an image view what its bounds are and what its center is and what its XY coordinates are. However, what's happening here is because transforms are handled a little specially. When you transform a UI image view, it's actually applied to the original coordinates. You're actually not moving the UI image view. So in a sense, if we were to pause execution, look in Interface Builder, the UI image view would still actually be there. But when rendered, it's being rendered with the translation and or scaling factor added in. So it's not actually physically moving that UI image view. It's applied later at rendering.
And those translations, you can't get those from the object.
Well, you could probably extract it from the property, but in this case, we're using our own storage to keep track of it. Yeah?
Well, if you have, like I said, if you have 2 images, each of them will call this handle, and the sender, using the sender, you can get whatever image is detected, and then you can get it translated.
So that's true. So I think the scenario being described, though, was if you have 2 images and those 2 image views and you click on one and drag that one, you don't necessarily want the other image to move. So if that...
But when you do that, regardless of the one you do, if you're doing them singly, one after the other, you will always be calling the handle pan, and the sender will be whatever you're moving.
So that is true. If you wired both such UI views to the same method, handle pan, you would always get a pointer to the correct UI view. But I think the point that we were making here is that this instance variable, underscore translation right now, would be accidentally shared between both of them. And that would be incorrect. Yeah?
Where is that underscore translation instance variable declared? Is it in some other file?
This was right up here. This was in my .h file. And as an aside, and I waved my hand at this before, the reason that this thing is actually declared as an instance variable here is because even though capital CG again suggests that this is a structure, almost always the CG prefixed items are structs, C structs. And so if we actually declared a property for it, you would find that you get into a predicament because you wouldn't be returning it by reference, you would be returning it by value, and you'd be modifying a copy of the CG point. And so long story short, it was very deliberate that we made underscore translation only an instance variable and not a property. Otherwise, we wouldn't be setting the right X and Y bits. Yeah?
Would it be best to store it in a CG point in order to keep track of multiple?
So you could, if you wanted to keep track of multiple images views, kind of like an iPhoto application where you can move and drag things around, especially on like the iPad where you have more screen real estate. Sure, that would be one such approach to keep around an array of CG points to keep track of the various translations that they've each engaged in. Sure, that would work. All right, so let's see how we got to this point, and then we'll just glance at the code for actually implementing scale. Yeah.
Can you pan and swipe on the same object? I don't understand how we tell the difference between pan and swipe.
Oh, good question. Can you pan and swipe on the same object? Let's see what the implications would be here. So Actually, the runtime distinguishes between those two events, so it wouldn't fire both. The idea is that Apple has somehow defined what a swipe is, what the speed is, though some of this is parameterized as to how long your finger has to be on the screen and so forth. But in that case, they would distinguish whether it's a swipe or it's a slower pan, for instance. Yeah, exactly. You just move it around like I was moving the rectangular face that was Tommy's. Good question. Yeah?
Do you have like just a special region like maybe on the bottom for swiping? And then maybe like
Sure.
area to be scanning and stuff like that?
Yeah, absolutely. So much like an e-reader, where different parts of the book's layout can actually be page forward, page back, main menu. Absolutely. You could create only a subset of the screen that actually responds to a certain gesture recognizer, like the bottom. Then you could put just some graphics of arrows to make clear to the human that he or she needs to swipe on that part of the screen. And absolutely. Then you would just attach, as we're about to do here with the add gesture recognizer method, to that specific UI view and not to the whole photo that's filling the screen. So that's a good thought too. So here then, to be clear, is how we would wire up the panning. It's actually pretty much identical to what we did before. This time though, we're using a UI pan gesture recognizer. Pointer there too. We're allocating one such object. We're initializing it with the target of myself, passing in the selector of handle pan, which again is that method we just looked at and I wrote myself. Then we are adding it to the image view, releasing the memory, and doing the same then for pinch, using exactly the same code except a slightly different class, this time for pinch recognition. And in pinch recognition, it too looks a little more complex in its final form than if we did it all from scratch, but realized that I needed to be careful to reapply any translation plus scaling in this method too, so that things weren't being reset accidentally to, say, the center of the screen if I first panned and then I went back and decided to pinch. I want all of these various effects to be cumulative. So I'm always adding in the concatenation of the scaling and the translation, and that's why the local storage, the instance variables and/or properties are helpful, because it's allowing me to remember my history of various gestures. So there are just 4 of the gestures that we can actually attach to all of these various views. Any questions? All right, so let's dive into one more juicy topic that can serve you well, perhaps, in your student choice projects, the spec for which will go out next week, but for which you've probably been thinking about, and by now you should have gotten feedback from your teaching fellow on your idea. If not, double check your spam folder and then email help@cs76.net and we will double check our own inbox. So you have a whole bunch of ways to actually store data in an application, and you're kind of seeing this already in the current Hangman project, whereby we've given you hundreds of thousands of words and we decided to distribute them to you via a property list. A property list is implemented underneath the hood. Recall, is just XML. It's an XML file, which for those unfamiliar is like HTML, but you get to invent your own tags. And the most important tag that is inside of words.plist that we give you for the Hangman project is an XML element called array. And inside of that array element are 250,000+ string XML elements, inside of which are all of the capitalized words. So we decided that a property list was a nice way of shipping it, and that you can actually poke around, you can see it very visually. The only downside is that Xcode tends to assume that a property list actually looks like, actually is a dictionary. So if I actually go to the projects page, and let me go ahead and download words.plist. It's about 6 megs. And then I go ahead and drag it into, I'm going to drag it into this Tommy project just temporarily so we can see it. I'm going to drag it into supporting files, copy it as I did the images, and then open it. Unfortunately, the UI for Xcode rather misleads you into thinking that this is a dictionary, because it literally says key and value, and then the string, the type in the middle. But this is actually Xcode's approach of showing you what an array looks like. So it is in fact an array. So if you are trying to load words.plist into an NS dictionary, it's not going to work. You're going to get back an empty such object. It's an NS array by definition in the spec. So now we have all of these words. Well, how else could we have shipped these things to you, and where else can you be storing data? So there's this thing called NS defaults. So NS defaults is an a special class that you can communicate with in order to save some amount, not a huge amount, but some amount of data related to your application. Maybe it's your IMAP settings if you're implementing a mail application. Maybe it's the length of words that the user wants to play hangman with. And so you'll see in the spec, if you haven't already, that we ask you to use NS defaults to remember the values of 2 sliders so that even if the user powers off the phone, terminates the application, you at least remember what kind of game it is they like to play, how long the words should be. Now there's an alternative. Those of you with iPhones and iPads will recall that you have that settings icon on your desktop, and you can go to settings to actually control a bunch of settings. For instance, the mail application, Safari has settings there. A lot of third-party application settings end up not in the flip side of a utility application, but factored out into the desktop settings tool. If you look around online in Apple's documentation, you'll see that those are called settings bundles, and it's actually not all that dissimilar to using NS defaults. But if you find that you're implementing application, especially for student's choice, that there's just a whole lot of options, and maybe you want to have multiple screens worth of options that conceptually a utility app wouldn't really lend itself to, at that point you can leverage the system-wide settings and actually package up your settings into what's called a bundle that's then accessible via the main menu. So the upside there is that you have a little more flexibility. You can make hierarchical menus, much like the Mail app, and you can really embed more widgets than you might want to on the back of your application. The downside, though, is that the user has to go futzing around trying to find the preferences for your application. So it really depends on the problem you're trying to solve. But we thought we'd look in a little more detail today at this third option here. Since it came up in our Android discussion, it can be used in various web contexts, and it's certainly all the rage. Or SQL itself is certainly still in great use in web applications today. And then we'll talk briefly today about XML and JSON options and later core data. So SQLite, recall, is a fairly lightweight implementation of a SQL database. But that database is not generally stored resident in memory. It's stored in a little file, a .db file, a .SQLite file, a .SQLite3 file. The extension can vary, but it's just a file inside of which are one or more tables. And those tables are like Excel spreadsheets with rows and columns and values stored in row form. So in iOS apps, you can start to store data in SQLite databases, especially if you want to start doing more interesting queries on them. So I'm going to go ahead and rather than do this one from scratch, I'm going to open tonight an application called SQLite. And actually, let me first open up plist just so that we see where we're going with this. This is a very simple implementation of a table view based application that's going to look in the simulator like this. I went ahead and stole words.plist from the project, and I implemented this. It's a ridiculously long and incredibly boring list of words to scroll through, because this will scroll through tens of thousands of times, but I argue that these are all of the words in the English alphabet, at least according to one dictionary. All right, so now those of you familiar with the iOS UI, you can imagine separating this into the A's and the B's, and you can have that little fast forward thing on the right-hand side like they do for all of your contacts if you want to zoom through them. But I just wanted to demonstrate getting information from a plist into this application. So how did I do that? Well, take a look in my root view controller. So I started off with this template, to be clear. The navigation-based application. I'm not really using it for what it's worth because it's just one screen that I have. I'm not using any hierarchy, but I just wanted a nice simple table view without implementing it myself, so I leveraged this template. And this template gives me a view controller. And if you scroll down, you'll see a few methods that I've left in here and implemented. Number of sections in table view. A section just refers to a grouping of menu options. I just have one, which means one huge long list. I only want to support portrait orientation just because. And now this is a more interesting method. Table view, cell for row at index path. So an index path is, as you may recall from section a week or so ago, it is a way of representing the hierarchical sequence of steps that a user has taken from menu to menu to menu. In this case, it's not all that interesting because I'm not using a hierarchy. I, again, just have one long initial view. So I'm only going to care about the row that it tells me the user has touched or that is being rendered. So how do I go about rendering all of these words? Well, this is boilerplate code that actually comes with this template, and you might have seen before. But at the top here, under the green comments, I'm essentially allocking one cell of a rectangular thing to put into this table view. There's a nice trick here for memory reasons whereby I can first ask the operating system, do you have any spare cells available that I can reuse so as not to allocate yet more memory? Because even though this list is going to be like 250,000 rows long, I only need to keep like 10 of them visible on the screen at once, which means I really only need 10 of those objects in memory at once. And in fact, as soon as the top one scrolls out of view, why don't I reuse that one, put him down here, essentially, and fill in a new word to that cell. So this is a wonderfully useful way of reusing memory and minimizing your footprint. But again, you'll see this for free in the template if you just create it from scratch. How do I configure the cell? Well, for now, know that I have an array called words. I've made it a property of myself, of the view controller, and I want to set the cell's text labels text value to be whatever the object is at the current row. So this method, for those unfamiliar, is going to get called again and again and again. Every time the user keeps scrolling up and up and up and up, this method's going to get called. It says the user wants to look at row 42. I have to then respond with a configured cell for what should go in row 42. All I did here with selection style is I didn't want annoying little blue backgrounding to happen when the user touches it. I just wanted it to stay white or gray. So that's all that method's doing. So the interesting question then is what is in what is in self.words? Well, let's scroll down here to view did load. So when you run this application, some stuff gets loaded from the nib, but not all that much. I have an opportunity now to load all of the words into memory so that I can start rendering them. Well, this is code that you might have seen in an online reference, or it's certainly something you can adopt for the project. Notice that here, I get back a reference to my main bundle, the folder, essentially, in which all of my applications, files, and directories are stored. What resource do I want? The thing called words.plist. So path, this is the name and the file extension. Then what do I do with this? I create a NS array, and I init it with the contents of that file based on this path. And it will figure out, the iPhone does have a file system. It's pretty much hidden from users, but this pair of functions will help us find words.plist. Then I remember this thing. Then I call release. Voila, I now have all tens of thousands of words loaded into memory. But some of you pointed out in the discussion board of late that this is kind of stupid, right? If the user is always going to play like a six-letter game, a seven-letter game, why are you loading all of these words into memory? Surely we can keep fewer of them around. Well, plist doesn't really give you all that many options. You have a couple of approaches. So if you're familiar with XML, you'll realize that, you know, I could maybe just parse the raw XML file, the plist file itself, and just look at each of the string elements in it and just ignore everything that's not, say, 6 characters long. So that's one approach. It kind of runs counter to the idea of having called it a plist in the first place. But what you would use for that is something called a SAX parser, S-A-X, which is a simple API for XML parser. To be honest, a SAX parser is generally pretty annoying to use. And it's pretty much what you get in the iOS framework these days. Whereas with JavaScript and other languages, you get a nice DOM-based representation. You get XPath functions and the like. On iOS these days, presumably for memory constraint reasons, you can't load a huge whole XML file into memory and then traverse it. So you pretty much have to let it fly by you, and you will have a method called, according to a SAX parsing, every time a new element is encountered. It's a little bit of an annoying way to parse XML, to be honest. So that's not an unviable route, but suppose I want to do something a little simpler. I remember from my web programming days that I could really easily say select star from table where length equals 6 and get back only those words. And if I have an index stored in my database, I should get those words pretty darn fast. I don't have to load them all into memory initially. So what I did was this. I went ahead in advance, much like we did a couple weeks ago, and I created a SQLite database. It contains exactly those same words. I dragged it into a new project called SQLite, and you'll see on the left-hand side here under my supporting files, I don't have the plist anymore. I've just got words.sqlite. Now, if I click on this, I can't actually see anything interesting because Xcode just doesn't have a built-in interface for SQL here. But it is a binary file inside of which is I claim a database of those same exact words. I had to do a few things, though, preemptively to make sure I can talk to this thing, as we'll see in a moment. One, every time we create a project set of templates, you pretty much only get UIKit, Foundation, and Core Graphics. You don't get this. So I actually had to go up to my project settings, go to the link section, and I had to add that to the list of frameworks I'm using. So if I can recall, I'm going to click my project at the very top left here. I'm going to go to Build Phases and go to Link Binary with Libraries. It really could not be less straightforward. And then I click this plus sign, and then I chose from innumerable other libraries that you might want to link against. But again, these are some things that will come up most likely in some of our seminars, things involving audio and video. And if you want some fancier features that you might not necessarily get out of the box, you need to tell the linker involved in Xcode that you want to know about those symbols. And I had to do one other thing, just FYI, if you decide to play with this for your student choice project. I also added this file here. I imported SQLite3.h so that I would actually have access in the IDE to all of the SQLite functions we're about to see. And autocomplete works because it then parses that file for me. So in short, to use SQLite, all you need to do is add the framework, and you need to add the header file, and then you're good to go. So what does good to go mean? Now, unfortunately, it's not always so simple. Unfortunately, SQLite is a C-based API. It's not Objective-C, which means it's kind of annoying to use, at least once you've gotten used to object orientation and you can instantiate classes and objects and methods and all this. We kind of have to go back to lower level details. However, there are third-party wrappers that you can download and incorporate if you want that make things a little more pleasurable to use. But we'll look at what comes built in. So here is my table view cell for row at index path method again. And it's actually unchanged, because when I actually display that list of thousands of words, I'm actually going to use the same code, but what's going to differ in this version of this program is I'm going to load self.words into memory differently. I'm going to do it based on the SQLite database instead of the property list. So let's scroll down to my viewDidLoad method. All right, so for those who recall SQL, this is really what's going to happen next. I decided that I only wanted to support 4-letter word versions of Hangman. Now, I could parameterize this and avoid hard coding the 4, but I just needed a simple lecture demo. So that's ultimately the query I'm going to select, and I want to use that to get back a result set and load only those words into an NS mutable array. So let's see how I do this. So this is the viewDidLoad method again. Notice at the very top, I call I alloc and initialize an NS mutable array. I'm making it mutable this time because I want to add one word to it at a time. I can't just load the whole thing into memory. That's counter to the goal at hand. I want to selectively load words this time. So now I declare a pointer to something called the SQLite3 object, or structure as it actually is. Then I declare a NS string called path, and I use some slightly familiar syntax. I'm going to ask, where's my main bundle? Where's the folder that this app is installed in? Get me the path for the file called words.sql. So this line is identical in spirit to what we did before with the plist, because it has nothing to do with the type of file. It just has to do with its path. So I figured out the path of my SQLite database. And now the next function looks a little funky, but you'll recall that the ampersand is from C. SQLite3 open that path, but I need to actually pass in the equivalent of a char star, not an NS string, since this is a C function, but path is an NS string object at this point. So path UTF-8 string gives me an array of characters, the name, the full path to that file. Now I'm passing in this DB pointer by pointer, so I'm technically passing in a pointer to a pointer so that I effectively get back an object in memory. So for those who never spent much time with C, this is sort of the old school approach of allowing a function potentially to return multiple values. I'm ignoring it for simplicity. SQLite3 open does return a sentinel value saying yes, this worked, or no, it did not. I'm just crossing my fingers to keep it simple that it will work. This is how you might return a second value, this one a structure, by passing it in by pointer so that the function can mutate it. All right, so how do I select all 4-letter words? This part's relatively simple. This first line, I create an NS string object, and I initialize it to @select word from words where length equals 4. That's it. Now I have to use this thing, so I create a SQLite3 statement. a pointer there too, and I'll call it statement. And now I'm going to prepare version 2. It's just slightly better than the old version. SQL 3, prepare v2. I pass in a pointer to the database, which I previously opened a few lines earlier. I pass in the char star version of the SQL statement. I hard code in -1 here, but I do pass in a pointer to statement so that my result set essentially ends up back in this thing. And then nil for now is going to be my last argument. So that's all that happened there. And now, almost there, now I get to actually iterate over the results. So while the SQLite 3 step function, when passed the current statement, returns an actual row, you can feel why this is kind of how C embraces a lot of things we take for granted in higher level languages now. We first grab a char star pointer to the result of calling SQLite 3 column text on the result set, specifically column 0. So this is a very simple table. It's barely even a table. It's just a column of words, but I wanted that filtration feature of the select. So statement, comma 0 gives me the first and only column. That gets stored in a char star, and I need that because next I'm going to create an NS string out of that, and I'm going to alloc that NS string. I'm going to initialize it with the char star so that finally I can put that string into my words NS array. And then I'm going to release that actual string, because the very last thing I'm going to do outside of this loop is finally retain this NS mutable array in my property called words, so that at the very end of this method, I now have created a situation that's almost identical to the previous version, except I filtered out all words whose lengths are not 4. So whereas I might be spending a little more uptime actually conditionally loading these words, now my memory footprint, frankly, is much, much less than it might have been in RAM had I loaded all of those words unnecessarily. Now, this isn't to kind of lead everyone into thinking, oh, this is clearly what they want us to do for the current project. It's not. It's to show an alternative so that when it comes time for the student choice project, you have a more sophisticated approach to actually storing and even writing data to files. But know that this is how we might apply it to something already familiar. So how about XML and JSON? So the iOS SDKs do come with built-in XML support, but fairly limited, namely this notion of a SAX parser, an NS XML parser. You can poke around with that if of interest, but do know that there are third-party libraries that make life a little easier. And certainly for the choice projects, you're welcome to incorporate those into your own project, so long as attribution is clear. JSON is kind of a funny one. JSON is kind of all the rage in almost every other language these days, and yet no iOS support for it, really. So here, too, there are a number of popular third-party frameworks that you can incorporate. We'll add some links to the course's website. TouchJSON is popular. JSON-framework is popular. And there's bunches of others, some wonderful, some not so wonderful. Frankly, just Googling around and getting a sense of their reputation can help you decide on libraries like that. JSON, recall, we used in the earliest project when we were doing things web-based. Core data is very interesting, and we'll continue this conversation a bit next week. But core data is essentially built on top of SQLite, and it provides you with a layer of abstraction so that you, the developer, don't even really have to know what SQL is. You don't have to execute low-level SQL statements, but you can model your data in a very object-oriented way, wiring up your models similar in spirit to what we've seen thus far in Xcode, and have to worry a lot less about the old school approach, if you will, of joining and inner joins and outer joins and all of that. So a little more on that and some 2D graphics next week. So that's it. Section's next, and I'll stick around to the side for any questions.